Hello students, so this is a question from Statistical Mechanics and I always tell you the question ID because you can search the videos, for example, of NET June 2024 just by putting the question ID on Pravegaa YouTube channel. Okay, so this question is linked to quantum mechanics and statistical physics. So here you can see a potential is given, which is asymmetric potential. Like this side you have potential infinite, and right side it is just a harmonic oscillator. So it is half omega square x square. So from quantum mechanics you already know that the energy values here, if I write, is n plus half h cut omega, but the value of n is 1357 dash dash dash. So this is the ground state, this is first excited state, this is second excited state, and this is third excited state. So here you want the ratio of number of particles in second excited state and third excited state. So this is second excited state and third excited state. So you know number of particles in second excited state and third excited state will be given by total number of particles into probability of second excited state and into probability of third excited state. Okay, so this will be n and n will cancel and this will be e to the power minus beta. So check for second excited state, it is 5 plus half h cut omega by z upon e to the power minus beta. Second excited state, so this is second excited state and third excited. So third excited state is 7 plus half h cut omega by z. Now this z and z will cancel and this will go in the numerator. 7 minus 5 will become 2. So it will become e to the power 2 beta h cut omega, and this half and half will cancel. Okay, so what is the answer? It is e to the power 2 h cut omega by beta is kBt. So e to the power 2 h cut omega by kBt. So this first is the correct answer. So just the knowledge of the energy eigenvalue of such a potential was required to handle this statistical system. Okay, thank you so much.